So, what if you could have an AI coding agent that doesn't just know how to code in general, but knows how to code in your specific private code base? For years, that's kind of been the holy grail, a dream really, reserved for these massive, well-funded labs. Well, a breakthrough from the Allen Institute for AI is about to change all of that.
Okay, just look at this comparison. It really tells the whole story. On the one hand, you've got the old way. We're talking tens of thousands of dollars, weeks of training, and this ridiculously complex infrastructure that's a total headache to manage. And on the other hand, you've got SERA, a few $100, training data that's ready in hours, and simple fine-tuning. This isn't just a small step forward, it's a completely different ballgame.
So why has this been such a tough nut to crack for so long? I mean, building a custom AI agent that truly gets the little quirks and patterns of a private repository, well, historically, that has required an absolutely staggering amount of resources.
You see, to get an AI to really learn your code, the old process involved these incredibly expensive reinforcement learning setups running on massive clusters of powerful GPUs. You'd also need these complicated pipelines just to create fake bugs for the AI to fix, a process that could easily take weeks just to get off the ground. It was slow, it was pricey, and it was pretty much out of reach for everyone except the absolute biggest players in the game.
But that is exactly where SERA comes in. It was developed by the Allen Institute for AI, A2, and SERA is designed from the ground up to be a practical, real-world solution that puts this amazing technology into the hands of indie developers and small teams everywhere.
And here is the number that just changes everything, about $400. Yeah, that's the estimated cost to fine-tune a state-of-the-art agent on your own code using SERA's method. It's an almost unbelievable drop from the tens of thousands it used to cost. I mean, that makes it accessible to pretty much anyone.
Okay, so how on earth is this even possible? How do you get that elite, top-tier performance for the price of a nice dinner out? Well, the answer lies in this really clever innovation at the heart of the SERA method. It's something they call soft verification.
So instead of running all these complex and super time-consuming unit tests to see if an AI-generated fix actually works, soft verification takes this ingenious shortcut. It basically has the AI generate the code patch twice, but in two different ways. And then it just compares them line by line. If they match up pretty closely, boom, it's considered a good training example. This totally removes the need for any test infrastructure, which is what slashes the time and costs so dramatically.
Here's a quick look at how that process actually works. First, a powerful teacher model gets a vague instruction, like fix a bug, and it just generates a code patch. Then, that change gets automatically summarized into what looks like a pull request. A description of the code change. Now for the clever part. The teacher model then tries to recreate the exact same patch using only that description. If the two versions it created have a really high overlap, you've just created a high-quality training example without ever running a single test. So smart.
All right, so the method is elegant. It's incredibly efficient, for sure. But the big question is still on the table. Does it actually perform? I mean, can this lightweight approach really compete with the more complex, expensive methods out there? Well, the data really speaks for itself here. On the popular SWE-bench benchmark, the 8 billion parameter SERA model gets a resolve rate of 31.7%. Now compare that to other open source models of a similar size. It's not just a little bit better, it is a massive leap in performance. It really proves just how effective the soft verification method is. But benchmarks, they only tell part of the story. A recent demo put SERA to a real-world test with a buggy Python script for a shopping cart. The developer's feedback was pretty stunning. He said, quote, "It has analyzed my shopping cart code and found 4 critical bugs, and it has provided me production-ready fixed code." Think about that. This model, running entirely locally on a single GPU, analyzed the code and found 4 critical bugs. We're talking stuff like missing keys that would crash the app and unhandled empty lists. And it didn't just find them, it provided production-ready code to fix them on the spot. I mean, this is the kind of performance you'd typically expect from a much larger proprietary model that lives in the cloud. So let's kind of bring this all together. What does a tool like SERA actually mean for you, for your projects, and for your team? What does this really unlock? Well, first and foremost, you get privacy and control. You can run SERA 100% locally, on your own machine. No data leaks, no sending your secret sauce to a third party. Second, there's that insane affordability we keep talking about, which makes this accessible to literally everyone.
Third is true specialization. This isn't some general-purpose model. You're creating an AI that learns the unique patterns and quirks of your code. And finally, it's fully open source under the Apache 2.0 license, which means you can use it for research and for commercial projects.
So it really leaves you with one big question to think about. From automated bug fixing to helping new developers get up to speed, what new possibilities open up for you and your team when your codebase has its very own dedicated AI expert?